All right, we're going to learn how in this lesson to factor trinomials with a greater than 1, also factoring completely, and then factoring higher degree polynomials. We're going to do a few different things in this lesson here. We're going to start off, we're actually going to go a little bit out of order. The factoring higher degree trinomials is dependent on the factoring completely, so we're going to do it at the end. So we're going to start actually here with factoring trinomials with a greater than or equal to 1. We've done this before. We're just going to use a different method. We're going to try to make a connection here between factoring and dividing. Okay? Remember the reverse tabular method? The reverse tabular method for dividing? We're going to use that method to find another factor once we know one factor. So they're telling us, okay, for 2x squared minus 3x minus 9, they're telling us one factor is x minus 3. So I know the answer is x minus 3 times something. I just don't know what that other something is. You're trying to find the other factor. Well, if you're trying to find another factor, you could just simply divide. So what we're going to do is we're going to divide. We're going to use that reverse tabular method to divide. So to set it up, we only need a 2 by 2 here. I'm just going to go quick through this because you already know the reverse tabular. All right, so it's not a matter of learning how to do that. It's just a matter of understanding the connection between this and the dividing and factoring. All right, so we know that we have x minus 3. That's given. So I'm going to put that on one side. And we already know we have 2x squared. And we know we have negative 3x. And we know we have negative 9. Okay, so we're going to go 2x squared has to be in the box right there. So what needs to be up here? Well, I already have an x here. This needs to be 2x. Okay, so if that's 2x and that's negative 3, I know it's negative 6x here. I know this diagonal needs to add up to negative 3x. So this must be positive 3x. And if that's positive 3x, this must be positive 3. And then 3 times negative 3 is negative 9, and my puzzle works. So what is my other factor? My other factor is my quotient. My other factor is what I got when I divided my quotient, 2x plus 3. So 2x plus 3 would be the other factor. So my answer essentially is 2x plus 3, the quotient when you divide. Okay, so they might not tell you this. They might not tell you use the reverse tabular method, right? They might just say find the other factor. You have to know, okay, I know one factor. How do I get the other factor? Factoring is just dividing. Oh, if factoring is dividing, I could just divide. I divide the two things they give me. Okay, so that's the connection we need to be able to make. Same thing here. This time we're going to need a 3 by 2. And again, for the reasons we already talked about in another lesson, I don't want to waste your time and bore you with those reasons. So you might have to go back and look up why it's a 3 by 2. All right, so here we go. We got x to the third. We have 2x squared. We have negative 13x. And we have, this should be a negative 20. And again, there can't be any remainders because we're dividing. These are factors. If they're factors, there can't be any remainders. All right, so this is x to the third. So what has to be up here? Well, this has to be x squared if I want to get times x to get x to the third. If this is x squared times 4, this must be 4x squared. My diagonal has to be 2x squared, so this better be negative 2x squared. If this is negative 2x squared, this has to be negative 2x. If this is negative 2x and this is 4, this has to be negative 8x. My diagonal should be negative 13x, so this needs to be negative 5x. Remember, you add along the diagonal to get negative 13. This is negative 5x, so this must be negative 5. And then make sure I'm right by multiplying by 4. I do get negative 20, which is what I was supposed to get. So what's my other factor? My other factor, so one factor is x plus 4. My other factor is just x squared, just x squared minus 2x minus 5. Okay? So that is my other factor right there. All right, we're going to move on to page 2 with factoring completely section. Then we're going to go back to that first section. Factoring completely. Factoring completely just means factor until you cannot factor anymore. You have to factor and then look at what you got and say, can that be factored more? If it can, you do it. Okay, and that's what you're always going to be doing from this point forward, is there might be more than one step to the factoring. All right, so for example, right here, I have a common factor, 5x. So I'm going to pull out that common factor, right? X squared minus 3x minus 4. But look what's left. X squared minus 3x minus 4. That can still be factored because we've done that, right? We factored trinomials with two binomials. Okay? X, 4 times 1, right? 4 times 1, give me 4, and then we'll subtract to give me 3, so I'm going to go negative 4 plus 1. There it is. So you wouldn't just leave 5x, x squared minus 3x minus 4. You would put 5x, x minus 4, x plus 1. There's actually 3 factors for this part A here. Here's another one, another common factor. I got 2, and I also have x squared. So 2x squared is my common monomial, common factor there. Okay, so divided out, I get x squared, and then plus 9x, and then plus 20. Okay, so that's 2x squared, and then again, x squared plus 9x plus 20 can be factored more, x plus 5, x plus 4. 5 times 4 is 25, and 4 is 9. So that B and A are almost the exact same example. These are a little bit different. Oh, keep flipping down there. All right, common factor here, 6. 6 goes into 54 as well, and x. So 6x is my common factor. What am I left with? X squared minus 9. 6 times 9 is 54. All right, now look at x squared minus 9. That can be factored more. Okay, 6x, x plus 3, x minus 3. Great stuff, huh? And then how about here? Difference of 2, you need conjugate pair again. X squared plus 4, x squared minus 4. Can x squared plus 4 be factored? No, it looks like it can, but it can't. A binomial cannot be factored if there's a plus in between it. The binomials with a positive cannot be factored. Binomials with a minus can. Okay, so I'm going to carry down x squared plus 4. I can't do anything with that. I can factor x squared minus 4. That can be x plus 2, x minus 2. So x plus 2, x minus 2 is the factors of x to the 4th minus 16. All 3 of these are the factors, of the x to the 4th minus 16. I'm going to jump back to the last page, finish this off here. Factoring higher degree trinomials. What if it's not just x squared, x to the 3rd, x to the 4th? We've done a little bit of that, but when they're trinomials and when the middle is half of what you start with, the middle exponent is half of what you start with, it works just the same as if it was x squared and then x. I'm going to show you what I'm talking about here. See how it's x to the 4th and x squared? This one's x to the 4th, x squared. This one's x to the 12th, x to the 6th. This has got to be half of this. This is half of this. When you have that situation, it can be factored. It's a shortcut. It can be factored with 2 binomials, just like it can be if it was x squared and then x. So x to the 4th, how do you break that up? X squared. And then multiples of 24, you're going to do it the same way as the regular trinomials. Multiples of 24. Okay, so how do I do 24? Well, I could do 1 times 24, I can do 2 times 12, I can do 3 times 8, or 4 times 6. What's going to give me 5? How about 8 and 3? 8 minus 3 is 5. We actually want 3 minus 8. We actually want 3 minus 8 because 3 minus 8 gives me negative 5. And there it is, x squared plus 3, x squared minus 8. So it's just like factoring x squared minus 5x minus 24. This would be x plus 3, x minus 8, right? But because this is double this and this is double this, the exponents are just doubled, it works the exact same way, okay? And that's that, okay? So now let's do these last 2 here. This one's a little different because it can be factored more. So this is going to be same thing, right? X squared. 12 is going to be what? 1 times 12, 2 times 6, 3 times 4. All right, I want a 7, so I'm going to do 3 and 4. I need a negative 7, so I need a negative 3 and a negative 4, and that does multiply to give me positive 12. All right, so x squared minus 3 cannot be factored anymore. It's a binomial, and that's an odd number there, so you're never going to be able to factor that. But x squared minus 4, ladies and gentlemen, we should already know that. X squared minus 4 is x plus 2, x minus 2. And there it is. You're done. X plus 2, x minus 2. X squared minus 3, x plus 2, x minus 2. That, remember I said you're going to need this factoring completely to go along with this. That's why I did this after I did the factoring completely. All right, and then I'm just going to erase because I need room. Erase this because I'm done with it. Now, x to the 12th, x to the 6th. Same idea. Okay? It's going to be x to the 6th, x to the 6th. I know this looks weird. You've never done it before, right? You'll get a hang of it. 45. 1 times 45, 3 times 15, 5 times 9. How do I get 4? 5 times 9. 5 minus 9 gives me negative 4. 5 minus 9 gives me negative 4. Just like you would factor x squared minus 4x minus 45. Same exact thing, right? You just got to make the exponents higher. All right? X to the 6th plus 5 cannot be factored. Again, you can't factor anything with a plus, but the minuses can usually be factored more. X to the 3rd plus 3, x to the 3rd minus 3. That does work. You might be thinking, wait a minute, 3 times 3 isn't 6. But what do you do when you multiply? You add the exponents. X to the 3rd times x to the 3rd is x to the 6th. It is. X to the 3rd times x to the 3rd is x to the 6th. So this does break down. X to the 3rd plus 3, x to the 3rd minus 3, and you're done because the 3 won't be able to be broken down anymore. Hopefully I didn't go too fast. Rewind it, rewatch any parts you weren't sure on, and we will practice these in class tomorrow. See you then.